In this video, we are going to be discussing how to simplify and multiply rational expressions. Rational expressions are going to be those like what you can see. They're going to be fractional expressions in which many times our variable is going to occur in the denominator, is going to be present in the denominator. So in order to do these, it's helpful to remember just some simple things with fractions, such as if I was doing, let's say, 12/8, and I wanted to simplify that. Well, one thing I can do is rewrite them using their factors. So I know a 12 is a 3 times a 4, and I know an 8 is a 2 times 4. So what I get there, 4 over 4 is just 1. Anything times 1 will just be itself, so that would simplify into a 3/2. In a lot of what we're going to be doing today, it's going to be exactly that. We're going to find the factors that will be common in the numerator and denominator. Those factors will eliminate, or they'll become the number 1. 4 divided by 4 is 1, which then just leaves us with whatever we had, because anything times 1 is itself. So let's take a look at how that looks with some more complex. So as I look at this one, I want to think of a number or a variable that can be taken out of every single term. So I notice they are all even, so I'm going to take out a 2, and all of them have an m. So if I take 2m out of the top, that would leave me just with a 5. 2n times 5 would equal 10, so still the same fraction, I just took out the factors. Then a 2m on the bottom, and we would have 5m minus 4. Okay, now 2 divided by 2 is 1. M divided by m is 1, which leaves us with 5 over 5m minus 4. All right, in this next one, it's a bit trickier. There isn't a single number we can pull out. They don't all have an m. In the top there, it does remind us of factoring. So that's exactly what I'm going to do. I'm going to try to think of what could multiply to give me the 42, and then add and subtract to give me a -1. So the number that comes to my mind is a 6 and a 7. So I'm going to start this factor. So we have a 6 and a 7, and we need to create a -1. So a positive 6 minus a 7 is what would create that -1, and the 6 times a -7 would create the -42. All right, so we've now factored the top of that. Let's factor the bottom. Both of those we can take out a 5, so I can rewrite the bottom as m, not plus, m minus 7. Okay, which is then going to simplify m minus 7 over m minus 7. That's a 1. And we're left with m plus 6 over 5. Now, up here in the directions, it said to simplify each. I've forgotten one extra thing we need to do, and state the excluded values. The excluded values are going to be values that are impossible. So there's some division that can just never be done, such as 5 divided by 0. This would be saying, if you took 5 things and divided them into 0 different groups, how many of that 5 is inside of each of your 0 groups? It doesn't really make sense. Whenever we divide by a 0, it's considered undefined. In these problems, we've got expressions such as this right here 2m, and this was our expression in the denominator. Now, our denominator cannot equal 0, so we want to figure out what are those numbers for which that denominator would equal 0. So let's start off first with the 2m. The 2m will equal a 0 when m is 0. So there, that's one of them. Next, our 5m minus 4. We want to know when that would equal 0, so let's go ahead and do 5m minus 4 equals 0. We could add a 4 to both sides, then we'd have 5m is equal to a 4. Divide both sides by 5, and m would equal 4/5. So then 4/5 becomes the other excluded value. All right, so that and that are both part of our final answers. Okay. Over here, let's look at what we had right there. We had that m minus 7. And we could say the 5 times m minus 7, but the 5 really isn't going to make anything 0. So let's just focus in on when m minus 7 equals 0. Add 7 to both sides. So whenever m is a 7. So for our excluded value, it would be 7. So there's the simplified form and the excluded value. I really wish that box would stop popping up. Okay. All right, so now let's do this. Definitely more difficult. First thing I'm going to do is take out any greatest common factors. Taking out the greatest common factors is going to make it so that we can then more easily approach any further factoring because the numbers will then be smaller. On the top, I notice I can take out an r. So I'm going to do that. We'll take out an r. Then we'll be left with 2r squared minus 23r plus 56. On the bottom, everything is divisible by a 6. Everything also has an r. The other thing I'm going to want to do is rearrange this. Notice how the r cubed is happening at the end rather than the beginning. I don't want that, plus I don't want it to be a negative. So I'm going to take out a negative 6r. Okay, and now let's begin rearranging that. So the negative 6r cubed, after we take out negative 6r, just becomes r squared. 18r squared, taking out the negative 6r, becomes a negative 3r. And then 240r, taking out a negative 6r, becomes negative 40. All right, so now that we've got those, now I'm going to want to factor both the numerator and the denominator before I continue with this. So I'm going to start right here with the numerator, and we're just going to focus in on just the numerator for a second. My first problem, I can't quite do factoring the way I did up here, where I just noticed that 7 times 6 could equal a 42. The problem is, notice here with this m, we don't have a leading coefficient, but down here we do. We've got that 2. So my first step here is going to be to multiply that 2 times by the 56, and I would get 112. And now I want to list the factors of 112. Now what I'm looking for as I go through these factors is I'm trying to find a number that when added or subtracted could give me a 23. And there we got it. So 7 times 16. So we're going to use that to split up that middle part. So we're going to have 2r squared minus 7r minus 16r. So minus 7r minus 16r would give us a negative 23r. So I haven't changed anything, I just separated those. And now I'm going to use some grouping. So first we're going to focus in on that. I can take an r out of both of those, and that would leave me with 2r minus 7. I could take out an 8 from both of these. Now this one starts out with a negative, but I want it to be a positive, so I'm going to take out a negative 8, and I will get 2r minus 7. Well, since both of those are 2r minus 7s, I can take out the 2r minus 7, and I would be left with r minus 8. All right, so we factored the numerator. Now let's make sure to factor the denominator. So we're going to have r squared minus 3r minus 40. Here we can just think what multiplies to give a 40, but could add or subtract to give a 3. And that number is going to be a 5 and an 8. We need to get a negative 3, so that would be a positive 5 minus 8. And that one's factored. So I can now rewrite what we had over here. It's now going to show up as r times 2r minus 7, r minus 8, over negative 6r times r plus 5, r minus 8, r over r is 1. r minus 8 over r minus 8 is 1, leaving us with 2r minus 7 over negative 6 r plus 5. Now, there is one mathematical convention, which is just an agreed upon way of doing things, where some old dead mathematician had told us that we don't want a negative in the denominator. Or at least we don't want that leading coefficient to be a negative. So we're going to change this negative 6 to a positive 6. And the way we're going to do it is if I change the signs of the denominator, I'll change the signs of my numerator. So notice how both of those on top flipped, and then on the bottom, that flipped. Okay, and there we go. Now that provides us with our simplified version. Remember though that we also need to find those excluded values, the values that wouldn't work. So let's take a look at each of these 3 elements from our denominator. So from the negative 6r, 0. From the r plus 5, that should be a negative 5. And from the r minus 8, that'll be 8. And there are the excluded values. All right, now when you multiply fractions, you're just multiplying the numerator to the numerator, the denominator to the denominator. So 15 times 2 is 30. 14 times a 19 is 266. Then we got a k. Now, just like I showed in that fraction example up above, we want to think of a number that we can pull out of both of those. Both of them are even, so I'm just going to pull out a 2. So 2 over 2 is 1, and we're left with 15 over 133k. I know that won't go any further because 15 only has two factors, a 3 and a 5. 133 is not divisible by 3, and it's not divisible by 5, so that's as far as I can go there. Next, over on this side. Now, this would normally be distributive property, and in fact, I'm going to write it with its parentheses first, and you'll see why I do that. It'll become obvious as I write it. So we're going to write this 8 times 49v squared minus 21v. That would be all over this 8 times 56v minus 24. Well, we've got 8 over 8, which will leave us with 49v squared minus 21v all over 56v minus 24. At this point, I would usually start looking for some number that I could take out of every term. Okay. Now, only 3 of them have a v, so I can't take out a v. If I look at the 49, I can think about what are all of its potential factors. Now, I chose 49 because it's got easy factors. It's just a 7 times a 7. That's the only possibility. So 49 could be divided by 7. 21 can be divided by 7. 56 can be divided by 7. 24 can't. And since 24 cannot be divided by 7, and 7 is the only thing we can divide the 49 by, that's as simplified as that one's going to get. All right. So now let's do this final one. This one kind of, it looks tricky. What I would start off with is before I'm going to do a lot of multiplying, what I want to do first is to factor everything I can. So rather than going through the process of multiplying 50n times 10n, 50n times 100, negative 80 times 10n, negative 80 times 100, and doing all this multiplication and allowing everything to just balloon out, I'm going to see if by factoring everything first, if that doesn't simplify things. So let's start with, I can take a 10 out of everything on the top. So I'd get 5n minus an 8. On the bottom, that's just going to remain a 10. I could also take a 10 out of both of those on the top, so that'll become n plus 10 all over. Now I don't see any particular number or variable that can be taken out of all of that, so I'm just going to leave it as 5n squared plus 7n minus 24. But now let's go ahead and focus more on that. Let's see if we can't factor that denominator statement a bit better. We've got this leading coefficient of 5, so let's go ahead and multiply 5 times the 24 to get 120. And now we want to list the factors of 120 and find which ones will help us to get a 7. So 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, and 8 times 15. Well, 15 minus an 8 could give us a 7. So there we've got our numbers. So we're going to split that 7n into 2 chunks. So we'll have 5n squared plus 15n minus 8n. Okay, and that's what we separated the 7n into, minus 24. So now I'll do greatest common factor of those two, greatest common factor of those two. So I can take out 5n from right here, and we're going to get n plus 3. And then from over here, I can take out a negative 8, and I will get n plus 3. So if I take out an n plus 3 from both of those, that would leave us with a 5n minus an 8. All right, so now that we've found that factorization, I'm going to rewrite our statement over here, 10 times 5n minus 8 all over 10 times 10 n plus 10. Then we have our n plus 3 times 5n minus 8. Now when you're multiplying, just numerator to numerator, denominator to denominator, and we'd get 10. There was another 10. Just putting my numbers first. Then I'll go ahead and put the n plus 10 and the 5n minus 8 all over. We add a 10 on the bottom, times by an n plus 3, times by a 5n minus 8. So 10 over 10 is 1, 5n minus 8 over 5n minus 8 equals 1. So that simplifies to 10 n plus 10 all over n plus 3. Now to know our excluded values, we want to focus in on what the denominator was before we eliminated anything. So the n plus 3, that's a 0 at negative 3. And the 5n minus 8, so if we added an 8 to both sides and then divided by a 5, we get that that will equal 0 at 8/5. And so there would be our excluded values. I hope this helps you guys out on the work. Good luck.